7, one of the easier ones. We are supposed to use energy consideration, assuming air resistance is negligible, to show that a rock thrown from a 20-meter bridge above the water at 15 meters per second is going to hit the water with a speed of 24.8 meters per second, and it doesn't matter which direction you throw it. That's right. You heard it correctly. If we are standing on a bridge, us, and we throw a rock off of that bridge to the water below, it doesn't matter whether we throw it out at that 15, what is it, 15 meters per second, or if we throw it downward at 15 meters per second, or even if we throw it upward at 15 meters per second. It doesn't matter which direction, it will still hit with the same speed. Okay, that doesn't mean it will hit with the same like directional speed, as opposed to like throwing it outward or throwing it downward. But you know, if it has an x component to the velocity and a y component to the velocity, the magnitude of that velocity is going to be the same, and it doesn't matter which way we throw it. How can we possibly know that? Through the conservation of energy. Okay, so if we throw it from up here, that rock is going to have what kind of energy? Yes, kinetic, and also potential, because we are on top of the bridge. Now, at the end, when it hits the water, what kind of energy does it have? Only kinetic. So you add up these two columns, and it should equal this larger column of kinetic energy. So what is the kinetic energy at the beginning? 1/2 the mass times the velocity, which would be 15 squared, plus mass times 9.8 times the height. How high is the bridge? 20 meters. And that's going to equal 1/2 the mass times the final velocity squared. Bye-bye mass, bye-bye mass, bye-bye mass. Here's where we see the speed term, 15 meters per second. So if we throw that straight up and we call upward positive, that means it's going positive 15 meters per second. But what if we threw it down? Then it would be negative 15. Well, what happens if I put a negative in here? Nothing, because we square it. Okay, so the energy, kinetic energy, is positive, not directional. So when we do 15 squared, we get 225, half of that, 112.5, plus 9.8 times 20, this thing, 308.5, and that's actually not joules because I divided out mass, but equals 1/2 final velocity squared. So without knowing the mass, I'll just multiply that by 2, take the square root, and we get 24.8 meters per second. Okay? And so to answer the question, it doesn't matter whether this is negative or positive, because when we square it, the kinetic energy is going to become positive.